Cool, so let's get started. This is going to be a dry run of a presentation I'm giving to a bunch of high school students in the future. And I thought it would be a great idea to just record the dry run because this is going to be prep I do anyways. Yes, I am home. Hello, Quick Draw. Okay, so what I want to do is just give an introduction to databases and a practical hands-on with SQL. And for anyone that knows any SQL, you probably are overqualified for this course. So the target student is really high school students, and we're trying to get them interested in technology. Okay, so let's get started. This is our agenda. We're going to do introductions. We're not going to do introductions in this format, but when I give the real presentation, we'll do introductions throughout all the students, and I'll introduce myself. And then we'll talk about what databases actually are. We'll go through kind of the pedagogical view of databases, the two main types, and kind of the purpose of SQL versus other languages. And thirdly, the most important part is we're actually going to write some SQL queries hands-on. And finally, we'll go through some review, and that's the agenda. Okay, so again, we're not really going to do any introductions, so let's skip that. What are databases? That's a great question. So let's talk about data first. I think that is fairly self-explanatory. It's just any piece of information. A database is a collection of that data organized and cross-referenced for quick retrieval. And you might have seen Excel or Access and used these tools in the past, but they're not quite databases. They're very, very close. It looks like it on the surface, but the big part is we actually can't retrieve that data very quickly. You can, in some sense, you can sort, you can do a lot of operations, but you can't get that data, let's say, in milliseconds. And so the real structure of a database is a system where we can grab that really quickly, the data that we want very quickly. Yeah, and that is database types. And there are two database types in general. Yes, there are a lot more. There's SQL databases and NoSQL databases. SQL databases are also called relational databases, while NoSQL databases are also called non-relational databases. We won't focus on any of the other types. I know some of you may know that there are graph databases or other types of databases that are very specialized, let's say for machine learning purposes, but in the real world, SQL and NoSQL take the largest market share of databases. And right now, SQL still takes the majority of the market share. So if you work at an enterprise company in the future, ideally after graduation, they are most likely going to be using SQL. SQL, what is SQL exactly? It is tables based. So think back to Excel. If we go back to the previous slides, it is just imagine an Excel table. That means we have like a header column. So here we have row number 3 in that Excel screenshot. That's a header column. And it tells you the schema for what all the data should follow afterwards. And so that brings us to the second point. There's a predefined schema. So the column names are set. And over here we have an example. There's contact name, address, and city, and just rows and rows of data. The column name is set, so that means we can't arbitrarily add additional fields to any row. Let's say we're taking that first row, Maria Anders, and we wanted to maybe add something else to that. Let's say we have a contact name, we have an address, we have a city. Maybe we also want to know the, let's say, country. We can't do that in SQL. We have to create a new column called country and have to add it to every single row. So it has a predefined schema. We can't just change that willy-nilly. It is older, but much more dominant in the industry. It is still dominant, and I will show you some charts for which database types are used most often later. Examples of relational databases. So we have a question. In some cases, could you just say, add the country name into the city column? Maybe you can, but that's kind of changing the purpose of that column entirely. So yes, that could be an option if you wanted to add country. You could change city into maybe location and then update the location for every single row. That's a possibility. If you really wanted to, you could add a new column, but just know if you add a new column, let's say country, you will have to add it to every single row. Okay, so that's SQL. It's very structured. That's what you should think. SQL structure. In fact, SQL stands for Structured Query Language, in case you didn't know. Examples of SQL, of relational databases, are really just all these variations of SQL. And we'll stick to that for now. So SQLite, Oracle, MySQL, Postgres, Microsoft SQL, all of these are a little bit of a different flavor. Oh, so I thought it was shorthand for SQL. It is not. It actually stands for something. So now you know. We talked a lot about SQL. Let's talk about non-relational databases. This is also known as NoSQL databases. This is kind of different. I think most people are less familiar with this because there are no really good examples that you may have used in everyday life. This is something that I really do like, though. I've actually taken quite a few MongoDB courses, and so this is actually my favorite database type. It is documents based. So before we said SQL was tables based. In this context of documents, we don't mean like a Word document or an Excel document. A document are these things. So if you take a look at that, this is what we call a document. There is a key value pair. And this in this type of format, we have a very flexible schema. For every row, we just insert a new document, and every document is just a bunch of key value pairs. So if we say, let's say, okay, here we have a country, but let's say we wanted to add a continent for some reason, we could add that just to one document or one row, and that would be okay. The other big thing about NoSQL is that it is much newer and it is catching up in the industry. Examples, MongoDB, that is the biggest one by far. And then we have a bunch of other ones like Cassandra, DynamoDB, Redis. How new is it? It is not that new anymore. I don't actually know exactly. I'm going to guess it's probably 10 years old. Maybe the very first iteration was that long ago. We could Google that later if we want to. Okay, but here I have some industry trends just so you know what you're getting into. NoSQL takes up about 40% of the industry. So if you work at a company and they have databases, you have a 40% chance that they're using a type of NoSQL database. And if you work at a company, again, there's a 60% chance they're using a SQL database. How does that compare to SQL? Oh, SQL is much, much, much older, probably pre-millennium. Yeah, and that's why this is kind of why it's more dominant within the industry, because it's been out there for so long. There's been many, many variations and iterations, and when we say SQL, there are so many flavors of it. Here we're just going to learn the basics, the kind of standard variation of it. And on the right-hand side, I have a more detailed breakdown. So MySQL takes up the majority of the SQL side, and MongoDB takes up the majority of the NoSQL side. And this is from 2019, so fairly recent graph. Okay, so we covered the two basic types of databases, SQL or relational databases, and NoSQL or non-relational databases. We'll come back to that in a bit, but the next thing I want to talk about is imperative versus declarative languages. This is a big topic because a lot of you, even if you're in high school, you might have learned a language or two, a programming language, but most of the languages you learn are very, very different from SQL. The languages that you learn are very likely imperative programming languages. This is where you tell the compiler what you want to happen step by step. It's okay if you didn't learn any languages. I think conceptually this will still make sense. So imperative, you tell the program or the compiler step by step what you want to happen. And some examples of imperative programming languages are Python, Java, C++, C Sharp, F Sharp even, literally any language you can think of, most likely. And this is where you write the for loops, the while loops, and all of that. You tell the interpreter step by step what you want to happen. Okay, we'll come back to that. I think it'll make a bit more sense once we contrast it with declarative languages. With declarative programming, on the other hand, you write code that describes what you want, but not necessarily how to get there. So you give the interpreter your desired results, but not the step-by-step. One good way to remember this is declarative. You declare something. You say, I want a house. Or, yes, I want a house with blah, blah, blah. And the interpreter, in this case, the construction manager, may have to go and figure it out. And examples of declarative languages, we're really going to focus just on SQL. But HTML is also an example of that. You tell the interpreter what you want, and the program figures out how to get there. It'll make more sense once we get to concrete examples. So here we have some concrete examples. If you were to build a house imperatively, you might have to build a foundation, put in the framework, install utilities, add walls, add finishing touches, blah, blah, blah. And so you say step by step what you happen. You are the construction worker here. But when you go ahead and try to build a house declaratively, you would say, hey, I don't really care how you build it. I don't care about the foundation or how you do it. Maybe you install the utilities first and then the foundation. I don't care. All I want is a nice fireplace, a big kitchen, a big garage, blah, blah, blah. So you describe the end result, and the construction worker figures out how to build it. Okay. Hopefully that makes sense. If there are any questions, feel free to put them in the chat. I am looking at the chat. Yes, so here now we have a more code-like example. Here I'm just contrasting SQL with something like Python. With SQL, we tell the interpreter, I want certain data from the table. I don't care how you get it. I just want that data. At first, it doesn't look that different. Here is an example of a SQL query. If you actually try to read it, it makes a lot of sense. So let's see. So there's an off-topic question. If you're writing in imperative language, would you say you start writing your code declaratively, then you actually go in and fill the details imperatively? That's a great question. Lots of times, before you write a program, there's a lot of design that happens, especially when you get into more complex programs. And in that case, you do write a lot of pseudocode. And pseudocode can be pretty declarative. And again, for anyone that doesn't know, pseudocode is just, it's not quite code, but you kind of tell it the instructions or the steps that you want to actually write in code. And so lots of times when you're designing programs, you might do it declaratively first, and then when you go and write the code, it has to be imperative because that's the type of language you're dealing with. So yeah, that's a good question. Okay, so between these two types of codes, we were talking about this SQL query. It makes a lot of sense, as I was saying, because from grocery items is a table. We'll get into the specific syntax of SQL later, but just by reading this, we can kind of figure out what we're trying to do. From grocery items, I want to get the price, select the price, where the product is apple. So really, I just said, I want the price of an apple, or in whichever, inside your store where you're selling all these grocery items, I want to know the price of an apple. So once you read the statement, it sounds very much like English. In imperative languages, instead of doing something like that, you would more likely, or you would have to, go through these for loops or while loops. Here I just have some Python. And As an example, you would say, okay, I want to go through each item in this grocery list. If that item is an apple, I want to give you the price of that apple. It sounds very similar at this stage still, but you can tell we did a lot more work to get to the apple price in the Python code than we did in the SQL code. And if none of that made sense, don't worry, we'll review it at the end. And maybe it'll make more sense as we start to write SQL queries. Okay, we have some check-in questions. I don't actually know how many people are viewing the chat, so if you want, you can pause for a bit if you're watching this afterwards and take a stab at these questions. I will just read them out now and give you the answers. So, true or false? MySQL is an example of a relational or SQL database where data is stored in tables and the schema is predefined. What do you guys think? Okay, so of course I don't have that many audience members right now. Yeah, so that is true. That is exactly what MySQL is. SQL, so question 2, SQL is an example of an imperative programming language where you tell it what you want and the interpreter figures out how to achieve the result. What do you think? I will give the answer in maybe 5 more seconds if I don't get any answers in the chat. Yeah, so I got false as an answer. That is right. It's false because I said imperative programming language. The rest of the statement is actually true, but what I just described is a declarative programming language where I declare what I want, and the interpreter figures it out for me. So yeah, the only part that's wrong with statement number 2 is imperative. 3, SQL stands for structured query language. I think this one is pretty obvious. It is true. I don't think I even had this in my slides, so I'm glad I mentioned it beforehand. But yeah, that's the check-in. With that, let's start writing some SQL queries. Okay, if you do want to follow live, navigate to this URL, copy and paste. I'll copy and paste it in the chat if I can. Here, let's do this. Copy and paste. And once you get there, go ahead and click the Run SQL button without any modifications. So here it's just creating a table. Don't worry about all of that just yet. Just run the SQL, the statement. I think I already had the statement, so don't worry if if you get an error. Maybe if you clicked it before. Then, okay, so you should have a bunch of databases on the right-hand side, which I do. Then you can delete the create table code inside. Wow, this pop-up is very annoying. But it just says delete the create table code that is inside the SQL statement box. Okay, so once you've done that, you are ready to go on to some hands-on SQL. Very, very exciting. You don't get it? Okay. Do you have a question? How much should I delete? Yeah, you can delete everything that is inside the SQL statement box, as long as you can see your database on the right-hand side. Hi, everyone. Okay. Are you guys prepared? Do you guys have your thing set up? Okay, and still, these exercises, you can do them without having the interpreter set up, but it is a lot easier to be able to visualize and actually run your queries. One funny thing is, actually in college, they make us write most of the code, at least for exams, on paper. And you think that's kind of weird, but you actually learn the same amount of stuff. It's just you don't have the liberty of an interpreter while you do the exams. Anyways, okay, let's go on to the first part of a SQL statement. This is the bread and butter of SQL statements, the select and from clause. Yeah, college is kind of scary. Hope you guys have fun once you get to college. From table name. So I have select here first, but I want to talk about from first. Here is saying which table do we want to look up data from. Oftentimes in databases, there's going to be a lot of table, and we want to figure out which table do we want to get data from. And then select. Select here is we want to see which rows we want. Oftentimes, well, I mean, almost always, there's going to be a lot of rows. You can use the star notation to select the entire table, and oftentimes we do that first just to get a sense of what's inside that table. If that didn't make that much sense, don't worry, we'll go through an example. So the example down here, if I can get this to disappear, is select star from students. This means there's a table called students somewhere, and we're just grabbing all the information from that students table. Okay, let's go on to the first question. We're asking you to complete a SQL query. That's a good question. I will get to that. Actually, capitalization doesn't matter, and I will go into more detail about that later. In the first exercise is we're going to get all the customers in the customer table. So all the data of customers in the customer table. And once you finish, your result should look like mine on the screen here. I'll give you maybe 30 seconds to do this. I don't think it's super difficult. The thing you have to know is there's a customer table. On the right here, you can actually see what tables you have. So we do have a customer table, and we want to select everything. And just for a quick review, remember if we want to select all the columns, we use the star notation. And here's an example of selecting something from a different table. It's okay. If you cheated, it's okay. So if you clicked on this, you kind of cheat a little bit. Just make sure not to click on the right side. Okay, let's get this out. So it's select something from something. We've already said we want to look at the customer table. And so let's do that from customers. And we want to select everything from it. And again, we use the star notation. So if we run the SQL query, we get all the customers in the customer table. So yeah, so far so good, right? If we take a look, that is the exact answer we get. Yeah, so don't worry about the square brackets. What they have here is a different notation. I would not use square brackets, and for most cases, you would not use the square brackets. Okay, actually, yes, let's go ahead and do the second select from, and then I will go over some caveats with SQL. I think I really wanted to get you guys writing some SQL first. So this one is a little bit more complicated. I want to return all the cities of the customers. So select something from something. This time, I don't want all the data. I just want the cities. I want a list of all the cities. Maybe you're trying to do some statistical analysis here. You're like an ML engineer, and all you want is to grab all the common cities. You want to take a look at just the cities, and you don't really care about all that other data. So take another 30 seconds and try this out. Okay, I think I will just go ahead and give you the answer. Yeah, that's awesome. If yours matches, that means you got it right. So again, we do want to select from the customers table. We mentioned that here, and we want to return every city. So instead of using the star notation, you just have to type in city. And that will give you all the cities, the city column only. And yeah, that's that. That is the answer. What does the semicolon do? Good question. Lots of really good questions. I actually addressed most of them here. Just because I wanted you guys writing SQL queries first, and then I wanted to get into some of the more caveats. So I think explaining all this in the void without you having written some SQL queries first makes a little less sense. So the first thing I want to mention is white space does not matter. So you can have a bunch of space here, and if you run the SQL query, you still get the same result. So I'll just show you that again. So white space doesn't matter. Generally, you want to only have one space after each keyword. That's the best practice. The next is you actually should be ending all of your statements with a semicolon. In this case, the interpreter doesn't care either way. If you don't, and yes, so white space does include different lines. And oftentimes when your query gets really, really complicated, you would separate the select, the from, and then space it out even more and onwards. Right now, our queries are pretty simple, so it's okay to keep them on one line. And that's really where the semicolon plays. If you have multiple queries, I don't know if it'll actually work in this interpreter. Let's say address from customers. You really want to start ending your queries in a semicolon. Let's see if that works. Nope. Okay. So not in this interpreter. You can actually have multiple statements. In most programs, you will actually be allowed to have multiple statements, and that's why you want to end it in a semicolon. The next thing is SQL is not case sensitive, though string values inside the table are case sensitive. We'll get to that in a bit. Just know anything you're doing right now is not case sensitive. So you can do select city from customers like that, but it is really, really not readable. And if you do that, let's say you're working for a company and that's your SQL query, you may get fired. This is also called SpongeBob case, in case you're wondering. If you learn nothing else from these lectures, just know SpongeBob case is where you alternate the capitalization of letters. So yeah, I'll just show you, just so you see. From, if I do this, the keywords have to be right, customers. If I do that, all works fine. And yes, so pedagogically, what we want to do is the keywords should be capitalized. So select and from, these are the keywords. We want those capitalized, and everything else should be lowercase. This makes your code very readable. So select star from customers. Actually, a lot of times in real life, it doesn't actually matter that much. This is how we like to teach SQL, but a lot of experienced SQL programmers will just use lowercase for everything. And I think the reason for that is there's actually pretty good syntax highlighting in these programs. So you can see select is blue and customers is black. And so oftentimes it doesn't really matter, but when we teach it, stylistically, we want to keep the keywords capitalized. Okay, so on to the next item. This is the where clause. Where, oftentimes, we don't want to just return the entire column from a table. We also want to filter some of that stuff out. And so where comes comes after the from statement. And here we have some type of conditional expression. What's a conditional expression? Don't worry about the definition too much. It's some type of condition we want to meet. We can use equals, greater than, less than, greater than or equal, less than or equal to. All of those are valid. As an example, we have some examples here. So select GPA from students where name equals Bob. Just by reading this, is less than valid. Less than is valid. Yep. I just did not put it up there. But yes, less than is valid. Select GPA from students where name equals Bob. Why is this useful? It's a good question. I'll get to that in a second. So select GPA from students where name equals Bob. Why is this useful? Let's say you were programming some software for school and the program says, okay, I want to know the name of a student and I will tell you the GPA of that student. And if you were a SQL or database programmer, you would likely write a statement somewhat like this. You would say, okay, there's a students table. I want the GPA of that students table, but I don't want all the GPAs. I don't want every single column. I just want the GPA of Bob. I just want Bob's GPA. And so another question that was just asked is, how would you do not equal to? It's a great question. I really didn't add these on there. And what's even weirder is in different flavors of SQL, it's slightly different. I will give you the syntax right here. So there is greater than, less than, greater than or equal to, less than or equal to, obviously equals, and then not equal In most interpreters, or at least older interpreters, it's actually like this. So you have a less than sign and then a greater than sign. But most modern interpreters will also let you do exclamation mark not equal. This is interesting because this is kind of the more common way, the exclamation mark equals. But this is kind of the slightly older way, and you can use either. I think for most interpreters, you can use either and it'll work. The other thing is, one thing to note is when we're talking about equality, we actually use a single equals. If you've been familiar with other programming languages, you've likely used double equals. So something like that. For example, in Python, x equals y is something you might use. In SQL, we always use a single equals. Why? Because in other languages, when we have that single equals, it's usually an assignment. So you would do x equals 5. But for select statements, there are no such thing as assignments. So let's go ahead and simplify it and not even worry about a double equals. So that's the reason we only have a single equals. And let me just walk through a couple more examples where you would use that where clause. The second one is select name from students where GPA is greater than or equal to 3.4. Again, you're at a school, or you're a programmer for a school software, and maybe this program also wants to know the names of all the students who have above a certain GPA. Let's say these students are on the honor roll. So your SQL statement that you write for this program will likely be something like that. You want to know the name of all the students that have a GPA of greater than 3.4. And last example is, let's say you were writing software for a, let's say a checkout. And the checkout scans a product name. Sure, it might be a barcode or something. Let's simplify it. It scans a product, and that product is an apple. And here we just want to know the price of that apple. And so if you were that programmer, this is the type of statement you would write. You want the price from products where the product name is an apple. Okay, let's go on to some questions. Writing about the where statement. So exercise 3, complete this SQL query to return all the customers in the customer table that live in London. Okay, I will give you a couple of maybe 30 seconds to 1 minute to give this a try. From what we know, I think the from is pretty straightforward, where we have the table name in the question, and we want to select all the information. So really the only thing I think that is new is the where clause. How do we format that? So we only see the information of all the customers that live in London. And yeah, the result will look something like this. In the meantime, I will format this. Okay, I will give you maybe 30 more seconds. Do any of you want a bit more time? That was probably like 10 seconds. Can't find a result. It's okay. I think one thing you can do is if you first want to see what's inside the table, you can get rid of the where at the very beginning and then write it afterwards after you get a valid statement out. So let's actually go through this part first. So the select and from we've done before. From, we know it's the customers table. So let's do that first. Customers. And we want to select everything. So it's a star. And once you get here, now you can add in the where. And the where is we only want to find the customers that live in London. I'll give you 10 more seconds and then I will go through it together. Okay, let's go through this together. What do we want to do in the where? We want the city to be London. Okay, so city equals London. This is actually it. Yes. I did say these were not case sensitive, but the values were. I should have mentioned, I didn't want to clarify there yet since we didn't actually have any values. So the values inside the table are case sensitive. So if you're comparing city equal to London, you want to make sure you have a capitalized L to match the values inside the table exactly. That's a good point. I think during the real lecture, I will make sure to mention that. So if you did just London, you will have no results. My other slide had Bob. Yes, it's a good catch. So I should probably change that where Bob is capitalized. That's a good catch. Okay, yes. So if you have lowercase l in London, then it doesn't give you any results. But if you have an uppercase L, then it will tell you all the customer names that live in London, or all the customer data, all the customers that live in London. Do you have to use a single quotation? I think I'm going to say yes. That is not necessarily true. I think this interpreter will allow you to use a double quotation. But in most SQL interpreters, yes. So it does let you use a double quotation. Most SQL interpreters will only let you use a single quote. The double quote does have a slightly different meaning that we won't get into here. Yeah, if you use a double quote here, it's not a huge deal. In most other languages, it's very interchangeable. Here in SQL, you always want to use the single quote. Okay, and here's the answer. We have one more where. So now we're dealing with a different table. We want to complete this SQL query to return the product name and price of all the products in the product table that cost less than $10. So this is your expected result. And just to quickly review the select again, when we have multiple columns we want to return, we use a comma to delineate which columns, to separate each columns. So hopefully that gives you enough information to complete this query. And at the end, your expected result should look like mine. I will give you 30 seconds. Go ahead and give it a try. I'll give you a minute. We'll say that. Awesome. So looks like we've got someone that matches. Let's go over this together. From, we mentioned in the question that we want to look at the product table. So not the customers table this time. From products, we want, what do we want here? We want the product name and price. I will do a star just to show you what the product table looks like. First, sometimes this is a good strategy. You can take a look at what the product table or whatever table looks like first, and then you can continue to the rest of the statement. So we know we want the product name and price. So select product name, comma price from products. And even if we want to, we could run it again just to see what that looks like. And we don't want anything expensive. Let's say we're trying to buy things and or Amazon has a lot of price filtering. Maybe you're working at Amazon and you're a database engineer there. If someone searches for something and they want it to be less than $10, this is the type of query you would write. Okay, and we'll add the where price is less than 10. And note, because this is a number as opposed to a string, we don't actually add any quotes. Okay, and this is what it looks like. You get all the items under $10. Great. Okay, how much time do we have? We have 10 minutes left in the real world. Can you add quotes? Actually, no, you can't if it's a number. Um, let's see. If it is a string, you can actually do a less than, and I believe it sorts it alphanumerically. So if you do a, oh, you can. Okay. So this is kind of the thing with different SQL interpreters. In this case, even if it was a string, this interpreter is letting you actually use that string to compare against numbers. There are other interpreters that are more strict, but it looks like in this case you can. I would still keep it as a number just for clarity. So yeah, probably best not to use a string here. Good question. Good question. Can you use, yes, you can use greater than or less than for strings. So comparisons will work and it will just compare it alphabetically. Okay, so last two items, hopefully we have enough time to teach this, is order by and limit. So both of these are, compared to the other three clauses that we learned, are just a little bit easier. Order by sorts whatever column name you want it to sort. Okay, another question. Would you get the same info if you did two different select statements? Could you ask that question a bit more? Or could you clarify? Would you get the same info if you did two different select statements? As you go ask that question, I'm gonna go over the order by and limit. Actually, yes. If you did select product name, you would get two different results. Yes, that's a good question. So you can do select product name. Yep, you get just the product name, and then if you do select price as a separate query, you just get the price. So it's not exactly the same. There are, I think, certain cases where you would want both. Maybe in this case, you wanted to print out a list. Can you do them like one after the other? Not in this interpreter. Even in other interpreters, it'll be printed out as two separate tables. So it will not be the exact same. So if you did, product name, here, let's do this. This is kind of what you were talking about. Yeah, and you would get a different result actually. You would get the first table with all of the product names, and then the second table with all the prices. You won't get them side by side as one row. So yeah, you can't do them one after the other. You won't get the same result. Okay, order by and limit. Order by just sorts your results. By default, SQL doesn't guarantee any ordering. So over here you can see the prices are all randomly ordered, just however they were stored inside the table. And so order by lets you sort the results based on a column name. So what goes after the select can be the same thing that goes after the order by. And by default, we'll just sort the numeric values from smallest to largest, and by default, we'll order string values alphabetically. There is a way to get to the opposite one, but we don't have enough time to cover that. And limit is another keyword. Here, you just specify a number, and this limits the number of rows that are returned. So oftentimes, when we have tables that have millions of items in there, we actually just want to see like the top 10 items inside the table just to get an idea of the schema. So I'll give you an example of maybe back to products. If I just want to see everything in products, from products, this gives us a lot of results. In other cases, this might be millions of results. We can limit it by adding this limit clause, limit 10, and it will only give me the top 10 results that are inside this table. So another question is, can you order by one column at a time? Can you only order by one column at a time? And the answer is no. So you can actually have multiple columns, just like the select. And that way it'll order by the first column first, and then if there are equal values in that first column, it'll order by the second column, and the third column, and so forth. So yeah, you can order by many different columns. And here I have some example. Let's say I wanted to see the 5 students in my class with the lowest GPA. I don't know why I have that as an example. But that's the example, and we're going with it. So again, we're selecting from students. I want to see everything about that student, and I'm going to add an order by GPA. And this will give me if I didn't have that limit at the end, no comma, so that is a typo. I'll need to fix that later, but no comma after each of the clauses. Limit 5, if I got rid of that limit, it will just give me all the students that sorted by lowest GPA first. And if I do the limit 5, then now I have just the 5 worst GPA students. Yeah, and there are use cases where sometimes you'll have to write a query like that. And that's a great question. No comma. So make sure to not have a comma after the clauses. A comma is only needed when you have more than one column name. Okay, exercise 5. I want to see the 3 cheapest items in the product table. And here I filled out some of it for you. And really, the 2 things you have to figure out are order by and limit. So go ahead and take a minute and try to do that. And in the meantime, I will type out this inside the interpreter. Yay, looks like we have someone that matches already. Select star from products. Order by and limit. Order by blank, limit blank. Okay, so let's figure this out. We want the 3 cheapest items in the product table, and we know we probably have to order by price in order to get the cheapest ones. If we didn't have the limit and we just ordered by price, what we would have is everything inside the products table just ordered by the cheapest item first. In this case, we only want the 3 cheapest items, and so we would add that limit clause at the end, and we'll just add limit 3. When we run it again, now we have the 3 cheapest items. Awesome. Okay, last exercise. Exercise 6. This is probably the most complicated of them all. We technically only have 3 minutes left, but we'll go over maybe by 2 minutes. What is the product name of all the items in the product table with a cost of $10? And I want to see the results ordered alphabetically by product name. Go ahead and try that. In the meantime, I will type it out. Okay, I will give you 30 more seconds, and then I will get on it. Yes, looks like we have another match. Awesome. All right, let's go over it. Again, we have a lot of stuff in this question already. The product table from products, and we want to select the product name. So these 2 we have, product name, and in the where, we only want the items that cost $10, not less than, not greater than, but exactly $10. So where price equals 10. And in case, if you didn't have this table out here already, you could have just run this again, just to take a look at what's inside the table. Select star. And from there, you could have continued your query. So now we know that one of the column headers is price. Price equals 10. And we want to order alphabetically by the product name. So we'll just type in product name here and run. Nice. So we have the 3 items that cost $10 ordered by the product name price. Okay, so that is actually it. Let's go through some summary. Okay, database basics. The two big things you need to know are the two types of databases and the two types of programming languages. Yes, there are more than that, but we're going to simplify it significantly here. Database basics, we have SQL databases, and those are also called relational databases. They have predefined schemas, tables-based, and a little bit older, but still much, much more dominant in the market. And this is what we did today. No SQL or non-relational databases. There's no predefined schema. It is document-based and much newer. This is something you may want to learn in the future. But it still has a smaller market share within the market. So another question is when you do where statement, can you do where price equals 10? As in without the spaces? Yes, you can do however you want. Spaces don't actually matter in SQL. So yes, you can do that. Okay, and the two types of programming we talked about, yes, there's some more, but these are the main paradigms. We have imperative programming and declarative programming. Again, imperative programming, you tell the interpreter what to do by step by step. Declarative programming, you're declaring something, you declare the result, and the interpreter figures out how to get there for you. And SQL is a declarative program. It still sounds like, oh, okay, these are just programming languages. They look very similar to me. I'm still writing code. But do you know that SQL, as you read more of it, you figure out that it sounds more and more like English to you. Yeah, it does really sound like English. I want the product name from products where the price is 10, and I want to sort it by the product name. It really is English in that sense. And in imperative programming, you have a lot of loops. In this case, I didn't tell it, oh, I want to go through each row. I want to write some type of sort in order to sort all the items. I want to compare each item's price. I didn't have to write all of that, so that's why SQL is a declarative programming language. And now, just going through each one of the clauses that we learned. Select, here we say the name of the columns we want to select. From, this is the table name. Again, select and from are the bread and butter of every SQL statement. If you don't have those two, you don't have a SQL statement. And from there on, where, here is where we can filter out some of the rows. Sometimes we just want one row, for example, Bob's GPA. Other times we want a lot of rows that meet some condition. For example, all the GPA that is greater than 3.4. Let's say we want to add them to an honor roll. And the last two are order by and limit. Order by is just which columns do we want to sort by. We want to sort by the values inside that column. And limit just limits the maximum number of results. Can where have multiple conditionals? Yes, it can. But in 50 minutes time, it is not easy to cover that. So yeah, you can write price equals 10 and let's say product name equals, I'll copy this, that. Actually, don't really need the price equals 10 because this is only going to return me one result anyways. But yes, you can have multiple conditionals. You can use and or, and a lot of other different operations. But right now, we're just going to learn one conditional. Okay, that is actually it. Anyone have any questions? Can you only pull data from one table? That's a great question. You're getting into the more complex operations, and the answer is no. Yes, from can have multiple values. I will show you this, but I don't expect you to go through a lot. The most basic type of join is a cross join. So when you select from two tables, let's say from products and customers, it actually cross multiplies the two tables together. So if I run this, look how many results I have. That is 91 times products, 77. So I don't want product name. Let me show you everything. Ooh, it's taking it a really long time. So that's why I didn't really want to show you joins. It can get complicated, and there are a lot of things that can happen. So this cross multiplies every single row in products with every single row in customers. And there are many other types of joins, like inner joins, left joins. outer joins. We're not really going to talk about that here, unfortunately, but that's a great question. From can have multiple values. Any other questions? Can limit have conditionals? No. So limit itself is only a number. You can only have a number afterwards. So if I do limit 10. Conditionals always go in the where clause. There are more complex ways to do it, especially if you have groups. But yeah, for limit, you only have a number that comes after it. Okay, any more questions? Okay, I think that is it then. If there are no more questions, thank you all for watching this dry run. I hope I can teach this very well to high school students next week. Actually, it looks like there's one more question. What if you want to do something like limit 3 cheapest items? Yep, so if you want the 3 cheapest items as we did an example of. Okay, go ahead and take some time to type out your question. If you want 3 items that have a lower price than 10, but 5 items that have a price above 10. I see. So that kind of gets kind of complicated. So 3 items that have a price lower than 10, but 5 items that have a price above 10. I see what you mean there. There might be a nice way when you start grouping items. So you can group by a lot of things. I would say that is probably too complicated to explain now, but yes, that is doable. You won't actually have it in the limit, but you can split your results into groups. And so there's another keyword maybe in the future you can take a look at called group by. And this lets you make subgroups within, and at the end you can have results. That gets a little bit more complicated. I would say for now, if you're playing around with SQL, definitely just write 2 queries for that. Oftentimes that's not a bad idea. Yeah, thank you for the questions. These are very thought-provoking. Okay, I think I will call it then. Have a great day, everyone. I will end the stream.